Graphing quadratic inequalities. All right, so graphing an inequality that's quadratic is not much different from graphing a regular quadratic, except the inequality symbol tells you which direction to shade and so forth. So in starting this, the first thing you actually want to have is a graph to actually graph the zone. And once you have the graph, you want to go ahead and find the vertex. All right, so you can use negative b over 2a. And then find alpha negative b over 2a. So if that's the case, start off finding this vertex, you should wind up having negative 4 divided by 2 times 1. So 4 over 2 is 2 for x. So now that part's 2. And the output should be 2 squared, subtract 4 times 2, subtract 5. So 4, subtract 8, subtract 5. Negative 4, subtract 5 is negative 9. So the y value is negative 9. So I know the vertex is at the point positive 2, negative 9. So it's about here. And if I want to find some other points, I'll try to factor this. Like I can kind of see that's factorable. So basically I know I got unlike signs because this is negative. So one's positive, one's negative. And I'm looking for two numbers multiplied by 5, and that'd be 4. So it's going to be negative 5, positive 1. So I know y is greater than that. So I'm looking for zeros. I can tell 1 0 is at negative 1, and another one is at positive 5. How? Well, you say each of those 0, that's what you get. So I know I have a point at negative 1, have another point at positive 5. Truthfully, that's enough to actually go and graph it. So I'm going to use just those 3 points. So given that, as a start for the graph, now let's get technical. For example, it said that y is greater than this. So to be greater than that, well, where does y get greater? Does y get greater down here? Or does y get greater above? Well, naturally, y gets greater as you go upward. So greater than means shaded above the graph. So I'm going to take a color, shade it up here. The other aspect of the graph says y is greater than with no or equal to bar. By saying there's no or equal to bar tells me my graph should be a checkered graph. So I'm going to go back and erase some of this. So there's not a solid graph. So the line isn't solid, it's checkered. Meaning if it exists on this line, it's not true, and if it exists outside of this line, it's not true. So none of those points would be good for the equation. That would be a false statement if you plug them into the equation. So this would be the graph for it, and that's how you graph inequality. So I'll pause the video, get that as a note, and I'm going to give you another one, so you actually graph that one as well. Okay, so in this video, in this section, we look at graphing systems of inequalities. So instead of just graphing one, you can graph 2 of them at the same time. That's basically what a system means. You're graphing multiple inequalities or equations at the same time. So let's start with getting the graph. All right, so let's graph this first one here. Looking at it, there is no b value, so it's actually really easy to find the vertex to it. So you're thinking about what that is. The b value is 0 because there's no b term there. So then my vertex for this one has to be at 0. When I plug back in 0, that goes away and gives me negative 2. So then my vertex is at 0, negative 2. This is a point there on the graph, and you can find other points on the curve, but essentially it pretty much looks like this. All right, and then we look at the second graph. Second graph needs a little bit more work. So to find the vertex of that, negative b over 2a is going to wind up being positive 2 over 2 times negative 1, which is going to be 2 over negative 2, which is negative 1. Now I'm plugging negative 1 back in there, and just so we know, that will wind up being negative 1, squared. So negative, negative 1. Subtract 2 times negative 1 plus 3. Making this negative 1 plus 2 plus. So plus 3 at the end. If you add this, this is negative 1 and 2, gives you 1 plus 3, which is 4. So I know that the y-coordinate is 4 for the vertex. So I know this vertex is at 1, 4, which is about right here. And this may be factorable. Factor out a negative 1 from all the x's, give you x squared plus 2x, subtract 3, making it 2 factors. Unlike signs, so one's positive, one's negative. And it's going to be 3 and 1 are the numbers sum to 2. So I know my zeros are x equals to negative 1 and positive 3. So I know I have 0 at negative 1, have another 0 at positive 3. That's not 3, is it? That would be 3. And I have enough of the curve, so I'm going to draw my curve through the first one, and draw my curve through the second point, and have them both. Now let's go back to the technicalities. We got the graph to it, now let's actually use the signs. For example, the first one has a solid line, so I know it's going to be a solid curve, and it says y is greater than, and I know that means I need to shade above. So I know this graph, I'm shading above. So everything up there is a solution. Second graph is a checkered line because there's no or equal to bar, and it says less than. So in that graph, I know I should shade beneath. And not only that, I need to make that line checkered. So I'm going to go back and erase pieces to it. So anyone follow my work and clearly see that it's not a solid line. All right, so with that being said, our solution is basically where both of them met at. So they're both met right here. So our real solution is just this little shape right here. This is solution to the system, which is a place where both of them have shading happening. So that would be the solution to the system, just a little darker area right there. I guess I use yellow. So just this area right here, where both of them cross. So that's how you graph a system inequalities. All right, so basically you graph each system of quadratic inequalities. You graph each of the quadratics, you shade them appropriately, and also make sure that the lines are either solid or checkered, and you have it. All right, let's move on. All right, so solving quadratic inequalities. And this is actually just solving the equation. We're going to talk about solving in multiple ways, graphically, algebraically, and also just using some intuition by recognizing what these signs tell you about it. Let's first look at a graph for it. So one way of thinking about this is, first thinking about this equation being y equals to x squared, subtract 7x plus 6. And thinking about the graph, this y equals to equation. You find a vertex, you find the axis of symmetry, and so forth. So I'm going to use the factors to go ahead and find the vertex, because I think this is factorable. So factor be x and x. Both have like signs, and both have to be negative, 6 and 1. So my zeros are 6 and 1. X equals 6 and 1. X equals 6 and x equals 1. So I know I have an output here at 6. I have a place to graph across there at 1. So it's both places that I have x-intercepts. I can find my axis of symmetry by getting halfway between there. That's about 5. So 2.5 way. 2.5 would be the middle. So 2.5 from 1 that'd be 1. This would be 2. This would be 3. So 3.5 is the midpoint right there. So I would plug in 3.5 for x. 3.5 subtract 6, and 3.5 subtract 1. This is a negative 2.5 times a positive 2.5, and together that's negative 6.25. So that'd be the y-coordinate of my vertex. So I'm sorry, yeah, y-coordinate vertex. So now should go down about 6 and a little bit more. It's about right here, maybe a little higher, around right there. And I have a curve I can draw. And that would be the line y equals that. Since it says this function is less than this, I'm only looking for where this graph is less than 0. And it says or less than with no or equal to bars. So here, it's actually an open circle. There's actually an open circle. So I'm going to erase a little bit of that out. Like this piece right here is an open circle. This piece is an open circle. So it doesn't really exist there. And this doesn't really exist there. Also, it says it has to be less than 0. So in this case, all these numbers, the graph is greater than 0. So you don't even want this piece. You can erase it off if you want. So that piece is not even important. The only piece that matters is this piece here. All those are places where the y value is less than 0. So you look for all the possible x values to make that happen. All the possible x values exist between this number and that number. So we say x is in between +1 and 6. So our solution is, when we're solving it, we're solving for x. We're looking for the values of x. So this graph only exists when x is in between 1 and 6. And the y value is going to be between 0 and 6.25. But keep in mind, we only look for x values, and x value exists in this section. Any x value other than that, like by plugging 8, output of 8 is going to parallelly be an output that's bigger than 0. If I plug in like 0, output is also going to be bigger than 0. Like you plug in 0 here and here, output 6. 6 is not less than 0, so it will be a false statement. So the only ones that give you true statements are x values in between this line, and those true statements would be those outputs. So anyway, that's one way of thinking about it. Another way of thinking about it is this. I'm going to erase this section over here, so if you need this as a note, I'll go ahead and get that down. But another way of thinking about it is using some intuition. I'm going to help you understand how to recognize the intuition. All right, so this is kind of helpful, kind of nice to know. Whenever you see this less than symbol, and it has to be set up with the variables on your left and the 0 on your right. This less than symbol, less than means and. If you remember from compound absolute value equations, it's pretty much the same thing. So whenever you see less than, just think and. And if you have trouble memorizing what's less than and what's what's less than and what's greater than, I always remember that if it's pointing to the left, it means less than. So it's pointing to the left. Like this is an arrowhead, pointing to the left, less than. Always made sense to me in 9th grade, so I always got it right. But so anyway, it's pointing to the left, it means less than. Less than means and this is a conjunction. It's a conjunction. That means in math is this. The solutions are conjoined to each other. So it means the solutions are next to each other, overlapping each other. So let's understand this. If we factor this, we get x. We factored earlier. I should remember what they were. Subtract 6 and subtract 1. So your solutions are +6 and 1. So I would just put that on the number line. I got 6 on the number line and 1 on the number line graph. And it says or equal, didn't say or equal to, so I'm going to change those to be open circles. So once you get that out of the way, I'm going to actually rethink about, okay, and is a conjunction. Conjunctions typically look like this. They're shaded in the middle. So since that's 1 and that's 6, I know x has to be in between 1 and 6. And that's how we literally write x is in between 1 and 6. We literally write it in between there with 2 less than symbols. So I can actually see that, and that's what it is. Had it been a greater than symbol, like x squared plus 1x is greater than 0, this we call a disjunction. This is an OR problem. So you got 2 different ends for your solution. So the solution look more like this. So one solution is at 1 and one's at 0, and they were shade opposite from each other. They wouldn't be conjoined, they would be going different directions. That's why we call it a disjunction. The solution would be x is greater than 1 or x is less than 0. And that would be the solution to that problem. All right, so with that being said, good luck.